Students, in this video lecture, we discuss about the Fourier series. So first we see the Dirichlet's condition. Any function f of x in the interval c to c plus 2l can be expanded as a Fourier series if the following conditions are satisfied. So the first condition is the function f of x is periodic in the interval c to c plus 2l. The second condition is the function f of x is single valued function in the interval c to c plus 2l. The third condition, f of x has finite number of discontinuities in the interval c to c plus 2l. And the fourth condition is the function f of x has finite number of maxima or minima in the interval c to c plus 2l. Now we see the definition of Fourier series. Let f of x be a periodic function of period 2l defined in the interval c to c plus 2l and satisfies the Dirichlet's conditions. Then f of x can be expressed as f of x is equal to a naught by 2 plus summation n running from 1 to infinity a n cos n pi x by l plus b n into sin n pi x by l, where a0, an, bn are called as Fourier constants or Fourier coefficients, and which are given by the formula a0 is equal to 1 by l integration limit from c to c plus 2l f of x dx. An is given by 1 upon l integration limit from c to c plus 2l f of x into cos n pi x by l dx. And the last one bn is given by the formula 1 upon l integration limit from c to c plus 2l f of x into sin n pi x by l dx. Now we see the Fourier series in the interval 0 to 2l. So the Fourier series of a periodic function f of x in the interval 0 to 2l is given by the formula f of x equal to a naught by 2 plus summation and running from 1 to infinity a n cos n pi x by l plus b n sin n pi x by l, where a naught is given by the formula 1 upon l integration 0 to 2l f of x dx. A n is given by the formula 1 upon l integration limit from 0 to 2l f of x into cos n pi x by l dx. And the last one bn is given by the formula 1 upon l integration from 0 to 2l f of x into sin n pi x by l dx. Now we have Fourier series in the interval 0 to 2 pi. So instead of l we have to replace l by pi. So we get the Fourier series of periodic function f of x in the interval 0 to 2 pi, which is given by the formula f of x equal to a naught by 2 plus summation n running from 1 to infinity a n cos nx plus bn sin nx. So here value of l is pi, so pi get cancelled, so we get cos nx and sin nx, where a naught is given by the same formula 1 upon pi integration 0 to 2 pi f of x dx. A n is given by the formula 1 upon pi integration 0 to 2 pi f of x into cos nx dx, and the bn is given by 1 upon pi integration limit from 0 to 2 pi f of x sin nx dx. Now we see the example. Find the Fourier series expansion for the function f of x equal to x, where 0 is less equal x less equal 2 pi. This is the given interval. So solution, we know that the Fourier series in the interval 0 to 2 pi, where f of x is periodic function with period 2 pi, that is f of x plus 2 pi is equal to f of x, which is given by the formula f of x equal to a naught by 2 plus summation n running from 1 to infinity a n cos nx plus bn sin nx. Now suppose this is our first equation, where a naught, an and bn are given below. Now in first step we have to find value of a naught. So to find value of a naught we use the formula a naught is given by 1 upon pi integration 0 to 2 pi f of x dx. Therefore a naught is equal to 1 upon pi limit 0 to 2 pi, value of f of x is x into dx. So taking integration, we have 1 upon pi into integration of x is x square by 2, limit from 0 to 2 pi. Now we put upper limit minus lower limit, so we get 1 upon pi 2 pi bracket square by 2 minus 0, because lower limit is 0. So instead of x we have to put value of x is equal to 0, so we get 0. Now by simplifying we get 1 upon pi 4 pi square by 2, and by simplifying we have value of a naught is equal to 2 pi. Now suppose this is our second equation. Now in second step we have to find an. So to find an we use the formula. An is given by 1 upon pi integration 0 to 2 pi f of x cos nx dx. Therefore an is equal to 1 upon pi integration 0 to 2 pi, value of f of x is x, so it is x into cos nx. Now we use the integration by parts and light rule. So by integration by parts we have 1 upon pi into x into integration of cos nx dx minus derivative of x with respect to x and integration of cos nx dx, limit from 0 to 2 pi. Now taking integration we have 1 upon pi into x into sin nx by n minus integration of sin nx by n dx, limit from 0 to 2 pi, as integration of cos nx is sin nx by n. Now simplifying we have 1 upon pi into x sin nx by n plus cos nx by n square, limit from 0 to 2 pi, as integration of sin nx is minus cos nx by n. So minus minus become plus and n into n is n square. Now we put upper limit minus lower limit. So we have 1 upon pi 2 pi sin 2 pi n by n plus cos 2 pi n by n square minus lower limit 0 minus cos 0 by n square. So by simplifying we get 1 upon pi into 1 by n square minus 1 by n square. So we get the 0. So this is our value of an. Now suppose this is an third equation. Now in last step in third step we have to find bn. So to find bn we use the formula bn equal to 1 upon pi integration limit from 0 to 2 pi f of x into sin x dx. Therefore now we put value of f of x equal to x. Now here we have to replace f of x equal to x. So note this step. Now again integration by parts, we have 1 upon pi into x into integration of sin nx dx minus derivative of x into integration of sin nx. Okay, again there is one connection, sin nx dx, limit from 0 to 2 pi. Now by simplifying we have 1 upon pi into x into minus cos nx by n, as integration of sin nx is minus cos nx upon n minus, again derivative of x is 1, so integration of minus cos nx by n dx, limit from 0 to 2 pi. Now by simplifying again 1 upon pi into minus x cos nx by n plus sin nx by n square, limit from 0 to 2 pi. Now we put upper limit then lower limit. So putting x equal to 2 pi we have minus 2 pi cos 2 pi n by n plus sin 2 pi n by n square plus lower limit 0 minus sin 0 by n square. By simplifying we get 1 upon pi into minus 2 pi by n. So pi get cancelled. So we have value of bn is minus 2 by n. Now suppose this is our fourth equation. Now we use equation 2, 3, 4 in equation 1. So equation 1 is given here. Okay. Now we put value of a naught is 2 pi. So it is 2 pi by 2 minus summation n running from 1 to infinity. Value of an is 0, right? So we have value of bn is minus 2 by n. We have taken minus sign outside into sin nx. Now 2 to get cancelled. So we have the last step f of x equal to pi minus 2 summation n from 1 to infinity sin nx by n. This is the required Fourier series of function f of x equal to x. Thank you.